Hey guys, sorry I'm not able to be with you today. I want to go over a few problems with you so that you can not be behind whenever I return to you. So the first problem that we have is the mean value theorem. And the problem that I assigned you for homework was f of x is 2 ln x plus 3. What you need to know about the mean value theorem is that in order to apply it, f of x must be continuous on the closed interval ab, and f of x must be differentiable on the open interval ab. In order to consider those ideas, we must 1. Look at a graph, or 2. Consider the natural domain of that function. First, I want to consider the natural domain of this function. The first thing that we know is that the natural log function cannot be negative and it cannot equal 0. So what we need to consider is what is going to make the natural log function equal to 0 or a negative number. So we just have to solve this simple fact. X plus 3 equals 0. So we know that when x equals negative 3, or when it's less than negative 3, f of x is no longer continuous. So how does that apply to the mean value theorem? Well, considering that the interval given to us was negative 2 to 0, and the natural domain of my function was anything greater than negative 3, we know that f of x is continuous on this interval. I can verify that by taking a look at this image that they've given us. Notice at negative 2 all the way to 0, the natural log function seems to be continuous. Now that we know f of x is continuous on that interval given, let's consider differentiability. Continuing to look at the graph, I see no cusps, I see no corners, I see no discontinuities. So since this function is continuous on that closed interval, and since our function is also differentiable on that interval, let's apply the mean value theorem. The first part of the mean value theorem that I'm going to attempt is the calculus slope. So what we're going to do here is we're going to take the derivative in order to find the calculus slope, and in the end, according to the mean value theorem, we're going to substitute c into our answer. This function is going to require a little bit of chain rule, but I'm going to skip that step. If you need to see that step, feel free to contact me and I can help you out with that. So the derivative that we're going to have here is going to be 2 over c plus 3. Notice I only put a c there because of what the mean value theorem tells us to do there. So I'm going to save this fact for later. And now we're going to find the algebra slope. The next step is I'm preparing for the algebra slope. So we need to evaluate f of 0. So I have 2 natural log of 0 plus 3 is going to be 2 natural log of 3. We also need to find 2 natural log of negative 2 plus 3. And what we're going to see here is that this is going to equal 0 because we know that natural log of 1 equals 0. Now that I have the y values, let's substitute it into our slope formula. So I have 2 natural log of 3 minus 0 over negative 2 over 0 minus negative 2. Okay, so whenever I do that, we end up with 2 natural log of 3 over 2, which is just going to give us the natural log of 3. Now for the slightly more difficult part of the mean value theorem, in my opinion, we are setting the calculus slope equal to the algebra slope. So I'm going to take both of those pieces that I found in those last steps, and we're going to try to solve for c here. So in order to do so, the first thing I'm going to do is I'm going to multiply by c plus 3 on the other side. In doing so, I'm going to have to distribute the natural log of 3 to c and to 3. Now I need my constants to be on the same side, so we're going to subtract 3 ln 3 to the other side. And remember, our common goal is to solve for c. That leaves us with c natural log of 3 by itself. So let's divide by natural log of 3 on both sides in order to get c by itself. The last step that we must do is we must verify that this number is in the interval -2 to 0. When I type this into the calculator, I get -1.180. Notice that falls within this interval, so we have applied the mean value theorem, and we have found our c to make this statement true. If you have any other questions about the mean value theorem or this problem specifically, feel free to save those questions for whenever I return. Thanks, guys.